Hello everyone, welcome to the Technogate. So take next problem here. So it's a very important problem here. So this is a function da function here. N equals to 2 raised to power 2 raised to power k here. For loop 1 to n, j equals to 2, while j less than equals to n, j equals to j square here. So suppose that k is greater than equals to 1. So if we take like k equals to 1 here, so right here, k equals to 1 here, then it goes to the n is 4 here. 2 raised to power 1 is 4 here. So now j equals to 2. So while 2 is less than equals to 4, yes, then it will execute here and j becomes j square means 4. So now 4 less than equals to 4, it will execute, j becomes 16 here and outside the loop. So it will not execute after then 16. Now k equals to 2 here, n is 2 raised to power 2 raised to power 2 means 16 times. N is 16 here. So j is 2 initially, it will execute. J is 4, it will execute. J is 16, it will execute. J is 256 now. So j is 256, so 256 less than equals to n is first out. So what is the value of k here? So what is the expression? So what is the notice here? So k is 1 here, loop will execute 1, 2 times here. What is the value of k is 2 here? So 1, 2, 3 times. So for every value of I, it will execute k plus 1 time. K plus 1 time. K value 1, 2 times. K value 2, 3 times. Now, what is the maximum value of I, n? So what is the expression here? So time complexity here, n into k plus 1. N into k plus 1 here. Okay. So nk plus n. So what is the higher order term here? Here nk. So nk, but the time complexity in terms of n here. So here n equals to 2 raised to power 2 raised to power k. So change the k in terms of n here. So take the log here. So log of n is log of 2 raised to power 2 raised to power k here. So this becomes one logarithmic property here. So log n is 2 raised to power k. Again k is not in the n terms. Again take the log. So log of log n is log of this one. So this becomes 1 again. So k becomes log of n here. Okay. So put k here. So n into log of n. So this is the time complexity of this program. So this is a very important problem here. Okay, so always convert k in terms of n here. So what is the time complexity? N into log of n. Okay, so this is a very important problem here. So this type of problem can be solved through the take any counter example. Okay, so for any problem take an counter example and solve the problem for the any program or any problems here. Okay, so let's take one more problem here. So again I already said that, so whenever you see the any multiplication, so j square is what here? J into j. So in the any loop like for loop or while loop, you see multiplication or division, then time complexity always in the logarithmic terms. Time complexity always in the logarithmic terms here. Okay, so this is the time complexity n into log of n. Clear? Now next one. Take next example here. So here input is given. What is the input here? An array of n elements here. Okay, and output is find minimum element. Find minimum element. Okay, what is the time complexity? What is the time complexity here? So here any array is given here. So through this array you find the minimum element, what is the time complexity here. So first of all, we see the approach, how to approach the problem. So suppose that take an array like that, 12, 7, 3, 6, 2, 0. So what is the approach here? What is the approach here? So first element, take first element is the minimum element. Okay. So here, first one is take first element as minimum element. Okay. So minimum is what here? 12. Okay. Like 1, 2, 3, 4, 5. This is index here. Now compare remaining elements with this element and update that element. So here 7 less than minimum, yes, update 7. 3 less than 7, yes, 3 update. 6 less than 3, no updation here. 2 less than 3, yes. 0 less than, yes. 1, no. So minimum element is what? 0 here. Okay, so there are n number of elements in the array. So for loop goes to the n times here. So take first element is the minimum element and compare. So there is a comparison. So this element compare with the all other elements. Okay. So compare that element with remaining n minus 1 elements. Okay, this one. So here first element is the minimum element. So minimum is a of 1 here, and this is a for loop. Start with the 2. I plus plus. So if a of I is less than minimum, a of I less than minimum, then update minimum here. So minimum is what? A of I. Minimum is what? A of I here, and this is the for loop here. So what is the time complexity of this statement? Is a constant one, and this loop goes to the n time here. So this statement execute n times here. So here, what is the time complexity here? So take first element is the minimum, then constant time, and there are remaining with n minus 1 elements here. So how many comparisons here there are? N minus 1 means n minus 1 comparisons. Okay. So what is the time complexity here? Here constant here, n minus 1 comparison is order of n. So what is the time for minimum element? Order of n. So if any array is given and finding the minimum element, then what is the time complexity here? Order of n. Order of n. And so in other way, an array of n elements is given, find the maximum element. What is the time complexity of finding the maximum? If we change like here, maximum, then what is the time complexity here? So here again, take first element as the maximum element. Here take first element is the maximum element here. And same approach, same. Compare that elements with remaining n minus 1 element here. So how to approach? So here what condition changes here? So take first element is the maximum element here. So what is the maximum here? First one, 1. Okay. Now 12 is compared with all other elements. So if any element greater than 12 is found, then update that variable. So here a of I is greater than maximum element. Okay, so update here maximum, then update the maximum here. So now execute this loop here. So maximum is first element. So 7 greater than maximum? No. 3 greater than maximum? No. 6 greater than maximum? No. Because maximum is 12. First element is the maximum. 2 greater than 12? No. 0 greater than 12? No. 1 greater than 12? No here. So what is the maximum element here? 12 here. So same order of n time it will execute. Okay. Now what is the third problem they can ask like what is the find minimum and maximum element. Find minimum and maximum element both. Okay. So what is the approach for finding the minimum and maximum here? So let's check here. So find the minimum order of n time, find the maximum order of n time here. So find the maximum and minimum, how much time it will take here. So let's check one. So again take first element is the maximum and minimum as the first element. Okay here. Now there is a for loop here. I is 2 to I less than equals to n, I plus plus. Now if that element is greater than maximum, then update maximum. So if a of I is greater than maximum, then update maximum. So maximum is what? A of I. Else if a of I is less than minimum, then update minimum. Then minimum is a of I. This one. Okay. So let's check this. So first element. So only for one for loop is there. Okay. And these are the statements. If is a statement, else is a statement here. So what is the time complexity here? Order of n. So find the maximum. Order of n time. Find minimum. Order of n time. Maximum both. Order of n time. Okay. So let's check. So max is 12 and minimum is 12. Okay. So here 7 here first one 7 greater than maximum, no. So condition false, then in else part 7 less than minimum, yes, update minimum. Again the for loop 3 greater than maximum, no, but 3 less than minimum, it is 3. Okay. Now 6 less than maximum, no, and 6 less than minimum, no, because 6 is bigger than 3. So again 2 greater than maximum, no, but 2 is less than minimum because minimum is 3 here, so it becomes 2 here. Now 0 greater than maximum, no, 0 less than minimum, yes, update minimum 0. Now 1 greater than 12, no, 1 less than 0, no, so is a maximum is 12, minimum is 0, this one. And correct answer is maximum is 12 and minimum is 0. Okay. So through this approach, take a counter example. So first of all, how to approach that problem. So make a counter example. This take an array and how to we solve this one and write the algorithm. This is simple. Okay. So it will take order of n time. So this type of problem asked many times in the GATE examination here. So take one more example here. It's an important problem here. So here an array of n integers in the range of 1 to n. Okay, this is the n integers, one like 1, 2, 3 up to. And what is the output is find repeated elements. Find repeated elements. What is the time complexity? What is the time complexity here? Okay. So how to approach that problem? Repeated elements here. So what is the first approach here? Then take 2 for loop here. Okay. Suppose that input is given like 5, 3, 8, 5, 7, 6, 7 and 1. So how many repeated element here? Output is what here? Repeated element is 5 and 7. So what is the worst case approach or brute force approach? Take 2 for loops here. So for I is 1 to n And for every element, compare all other elements every time. For j equals to 2, j less than equals to n, j plus plus. So if a of I and a of j are equal, then return a of I, your element. Okay, so this approach is okay, but it takes more time. How much time? There are two nested for loops here. Two nested for loop here means there are order of n square time it will take. How much time it will take? Order of n square time it will take. Now, what is the best approach here? What is the best approach here? So, first algorithm is algorithm 1 here. So it will take n square time. Now, let's check the another approach. Okay. Okay. So here we have to take then extra space. Extra space. Okay. Like a flag array. Okay. So first approach is what? Take a flag array of size n. Take a flag array of size n here. Okay. So and all initialized with 0. All initialized to 0. Okay. Suppose that so. There are 1, 2, 3, 4, 5, 6, 7, and 8 here, and initialized with 0. Because there are n, so range 1 to n, like, so suppose that input we are taking like a 5, 3, 8, 6, 5, 7, 6, and 1 here. So range is up to 8. Okay. So take a flag array of size n and all initialized with 0 here. Now take a loop, for loop here, I is 1 to n. So first of all, check the flag value of that element here. If flag value is 0, means comes first time, then make it 1 here. Make it 1 here. So what is the approach here? So if flag value of that element is 0, then okay, then flag is 1. Then flag is 1 here. Create flag is 1. So flag of a of I becomes 1. Else print I. Print a of I here. So now we have to check here. So initially, okay, I is 1 here. So 5 comes here. So flag value of I means first element is 0. So make it 1 here. Okay. Next one 3, then first time 1 here. 8, first time 1 here. Then 6, first time, then make it 1 here. Now 5. So flag value of that element is 0. No. Then this element appears second time. Okay. Then first element is print 5. Output is 5. First one. After that 7 come first time, then make it 1 here. Then 6. Flag value of 6 is 0. No. It becomes, it already 1 here. Means it appears second time here. Then 6 here. Then 1. So what is the repeated element here? 5, 6. 5 and 6. Okay. So here, what is the time complexity here? Order of n, because 1 for loop here. So time complexity here. So time is what here? Order of n. But here we are using auxiliary space, extra space of size n. We are using an extra space of size n here. Okay. So here space consuming is order of n. Okay. In the first approach, time complexity is order of n square. There is no extra space we are using. But here there are time is order of n. Okay. But space order of n. Extra space we are using. Okay. So whenever user uses extra space, then space will be counted here. Okay. So extra space because we are taking not compile is taking, we are taking extra space here to counter the variable. Okay, is it already comes or again comes here? Okay, so time is order of n and space is order of n. Okay, so this is take flag means extra here. Okay, so what is the time here? Order of n and space is order of n. So this type of problem asked many time in GATE or any interview examination or any competitive exam. So this type through this approach we can solve it. Okay, so we will take more number of GATE problems in the upcoming lecture. Okay, guys. So we will meet in the next upcoming lecture.